Welcome back. So far, we have discussed the concept of entities, attributes, relationships, and cardinality constraints. All these are key elements of an entity relationship model. In this video, we are going to discuss how we can represent an entity relationship model as a diagram, focusing mainly on how we can represent cardinality constraints in the diagram. So, let's start with the simple things first. Entities are typically represented as boxes in the diagram with their names on top. The attributes of the entities are either written inside the box or we list them sometimes as bubbles connecting to the box. By convention, we also underline the primary key to know which attribute plays that role. Next, to represent relationships between entities, we draw lines between the entities and we often put the name of the relationship within a diamond. So far, pretty simple. Now, let's see how we can represent the cardinality constraints in an entity relationship diagram. We are going to discuss one of the most commonly used notation conventions that we call the Krauss-Foot notation. There are many other ways of representing cardinalities in a diagram, for example, the Chen notation, the UML notation, arrow notation, and many others that we'll not be discussing as part of this course. They are pretty simple once you know one of them. Now, let's see the basic elements of the Krauss-Foot notation. We start by having three basic symbols: the symbol for 0, the symbol for 1, and the symbol for many, which we are going to use to create our notation. And you might ask, why do we call this notation the Krauss-Foot? Because if you see the symbol for many, it looks like a Krauss-Foot. So that's the reason that we call it Krauss-Foot notation. So how do we use the symbols? We use the symbols and we draw them on the two sides of the relationship, connected to the entities, and we use the symbols to show the participation, the minimum, and the key, the maximum, cardinality constraints for the relationship. For example, when we have a relationship with mandatory participation, which means minimum 1, and with maximum cardinality or key constraint of 1, then this symbol is being used to specify the cardinality constraint for that relationship. If you take a look at the symbol, you'll see that it combines two 1 elements, one for the minimum of 1, which means mandatory participation constraint, and another one representing the maximum cardinality of 1, the key constraint. When we have an entity that has mandatory participation, minimum 1, and the key constraint is many, then this is the notation for the constraint of mandatory participation and with many as maximum. Notice how the symbol is created. It combines the 1 element on the one side with the many element signifying the minimum of 1 and maximum cardinality of many. Now, when the participation constraint is optional, then the symbol that signifies the minimum participation becomes 0. So here is the notation that we are using when we have optional participation, again, minimum cardinality of 0 and maximum cardinality of 1. So take a look at the symbol. Now we have combined the 0 element for the optional participation constraint with the 1 element signifying a maximum cardinality of 1. Finally, here is the notation of minimum cardinality 0 and maximum cardinality of many. This symbol signifies optional participation in the relationship with the 0 element, and with the many element, we show the maximum cardinality, which is many. We have seen the 4 different notations. Let's see now how we can put them down within a diagram. Pay a little bit of attention here because it can be a little bit confusing at first. Let's see a few examples that show the symbols that we discussed being used as part of a diagram. Let's say that we have an entity course and we have an entity offering. We have the relationship that each course has offerings. Now, let's examine the cardinalities as they are written in the diagram. On the one side, we have that each offering has at least a minimum of 1 course associated with the offering, and it also has a maximum of 1 course associated with an offering. This means that each offering has at least 1 and at most 1 course associated with it. So the Krauss-Foot notation is minimum of 1 and maximum of 1. Now, on the other side of the relationship, we have that each course can have potentially 0 offerings, which is the minimum, and each course can also have many offerings as the maximum. So notice now the representation is of minimum cardinality of 0 and maximum cardinality is many, following the Kraus-Voot notation. Pay attention to the pattern. When we are creating the diagram and we are specifying the relationship, we are always looking at the symbol on the other side of the relationship. So, to say that the course has 0 to many offerings, the symbol for 0 to many is attached to the offering entity, not to the course entity. And vice versa, the fact that the offering has at least one and at most one course is represented by the appropriate symbol, which touches the course entity. This is a very, very common source of confusion, so pay attention to that part. Let's take a look at this diagram now. Say that we have a student has account relationship. The notation that we see means that each student can have at most one account, but sometimes the student may not have an account. The minimum cardinality is 0. So we have minimum cardinality 0 and maximum 1. On the other side of the relationship, a student account needs to be associated with a student, which means that the minimum cardinality is 1, and we also have maximum cardinality of 1 as well, which means that each student account cannot have more than one owners. So we have the constraints that a student account cannot exist without a student associated with it, and the account can have at most one student associated with it. Notice this is a restriction that we put ourselves as part of the model, trying to model how an organization works. This model again, says that each student account cannot be associated with multiple students, and we don't allow as part of our model to have multiple owners of a student account. Again, these are assumptions of the model. These are not necessarily a universal truth or a universal reality that we accept as a given fact. There might be organizations where they allow group accounts for students. In that case, when we are creating the diagram for that organization, we're going to put the appropriate notation there. We just need to know for the organization that we are modeling how the organization works, what is allowed and what is not. Let's take a look at another example. We have departments and professors. Each department has professors and each professor has a department. Let's take a look at the relationship cardinalities and what they mean. What we are saying in the diagram is each department has a minimum of 1 and a maximum of many professors. Therefore, our model says that we cannot have a department which does not have at least one professor associated with it. On the other hand, we have a professor that has a minimum of 1 and a maximum of 1 department. This modeling assumption says that the professor cannot be associated with multiple departments, and also that we cannot have a professor that is not associated with any department. Again, this is a modeling assumption that is expressed by this diagram. It is not necessary that all departments and all universities obey the same rules. As we're saying, this diagram expresses the rule that the organization follows. Finally, here is another relationship. We have students who take courses, and what this diagram is saying is that when a student is taking courses, a student may or may not take courses as the minimum cardinality is 0. So we allow a student to exist in the database without taking any courses. And of course, each student has a maximum of many courses that a student can take. On the other side, we can see that each course can have 0 students to many. So we may have courses that have 0 students, and of course, each course can have multiple students. To wrap up, let's review what we discussed in our first lesson. First, in an entity relationship diagram, we have entities. Each entity is described by a set of properties, which we call attributes, and each attribute has a domain of values. For example, each student has a student name, student ID, age, and sex. Each course has course ID, section ID, course description, and the location, and so on. Typically, each entity has an attribute whose value is unique for each instance, and this is what we call a primary key. Now, entities have relationships with each other. So, for example, a student can take courses, a course is taught by an instructor, a student has an advisor has an office, and so on. These are all relationships between entities. And a key part of the relationship modeling in the ER model is the cardinality modeling. Cardinalities describe the limits of how many instances can participate in a relationship. So, cardinality constraint specifies the maximum and minimum number of relationships that each entity can participate in. ER modeling may seem a bit strange at first, but once you practice a bit, things become much easier. So, play around and practice. See you next time.